equation of y is equal to 3 4x minus x squared to the 3. If I took the derivative of this, we know it's derivative of the outside times derivative of the inside. So we're going to bring that 3 down. So we are going to have our 9, leave the inside alone, subtract 1 for that 2, and then multiply that by the derivative of the inside, which is going to be 4 minus 2x. Okay, easy peasy. But my question to you is, what happens if it is 3y cubed instead of a function? Well, if I want to take the derivative of 3y cubed, it's the same type of thing. I'm going to bring that exponent down. I'm going to take the derivative of the outside, so I'm going to have 9y squared. But instead of multiplying by the actual derivative of the inside, I'm going to multiply by y prime, because I don't know what the derivative of y is, so I just write y prime. That is all that implicit differentiation is, okay? So we use implicit differentiation because we can't solve the equation such that it's y on one side of the equality and x on the other. And so it's just simply us using the chain rule, recognizing that we know y is a function of x and that y prime exists, okay? So we're going to use the chain rule, and when you take the derivative of y, we're basically going to write dy dx after each time you differentiate a y term. And you can write dy dx or you can write y prime. It's whatever you like. The key here is at the end, we have to isolate for that dy dx or y prime. So if I'm looking at the function of y cubed minus y times ln x equals 4x squared, if I take the derivative of y cubed, that is going to be 3y squared, but the derivative of the inside is y prime. Don't know what that derivative is. I just write, hey, it's the derivative of y, whatever y happens to be. I have to watch here because this negative y times ln x, this is actually a product rule. Remember, y is a secret function of x. We don't know what it is, but this is just one function being multiplied by another function. So when I go to take my derivative here, I'm going to take the derivative of the first. So the derivative of negative y is negative y prime. Leave the second, ln x. Leave the first. What's the derivative of ln x? 1 over x. So this is our product rule. We just use the product rule there to tackle the derivative of y times ln x. Equal to, on the other side, what's the derivative of 4x squared? Simply 8x. Now this is a problem where we're going to have to rearrange and isolate our y prime. So the approach here is always going to be kind of the same. We're going to bring all y primes to the same side. Anything that doesn't have a y prime in it, kick it to the other side. So we're going to be left here with 3y squared y prime minus y prime ln x. There's no y prime in this negative y over x, so I'm going to take that to the other side and it will become positive y over x. And then I want to factor out my y prime. So I'm going to have y prime is equal to, or y prime, and once I factor that out, what I'm left with is 3y squared minus ln x. And the beautiful thing here is that now that I factored out the y prime, I can divide both sides by whatever isn't y prime, and I'm left with getting y prime by itself. I don't need to make this pretty, I just need to get y prime by itself. So I'm going to have 8x plus y over x on the top divided by 3y squared minus ln x on the bottom. There is some further simplification if you want to do some weird math there, but honestly, you just need y prime by itself. So let's try this again. If I have y squared is equal to x cubed e to the 2y, we're going to have to use implicit differentiation. We've got y's on both sides of the equal signs. This is an implicit differentiation problem. So when we take the derivative of y squared, we're going to have 2y times, what's the derivative of y? I don't know, y prime. On the other side of the equals though, have to watch, we have again a product rule. So derivative of the first, keep the second, plus keep the first derivative of the second. So the derivative of x cubed, 3x squared. We keep that second one, so it's just e to the 2y plus keep the first, so x cubed, and my derivative of the second, the derivative of e2y, derivative of anything with e is we just write it down, and then the derivative of the exponent, well, the derivative of 2y is 2, but then what's the derivative of the y part? Y prime. What do we have to do? We have to bring everything with a y prime to the same side. So I'm going to have 2y y prime minus x cubed e to the 2y prime. And I'm going to have this 3x squared e to the 2y on the other side. Now I factor out that y prime, pull it out, and leave whatever we've got left. So 2y minus x cubed e to the 2y. And then we can divide both sides by whatever we're multiplying that y prime with. And again, this isn't pretty, but the point here is just to get y prime by itself. And there we go.